solve for. E is not a variable. This is, I want to say, it's like pi, where it's got a decimal that goes on forever with no pattern. There's no way to write it as a fraction. The E value, it's what we call an irrational number. But it shows up a lot of times in formulas for banking it's used for continuous growth and decay, which is, we'll do that in a couple of days when we do our compound interest. But I'm literally just going to introduce you today to E. So this, you can type this into your calculator. There's a button for it. It'll give you the first few decimal places, but it is an irrational number. There's a decimal that goes on forever with no pattern, cannot be written as a fraction, so we call it an irrational number. So exponential functions that have the base E is what we're going to work with today, but it's either continuous growth or decay. Now, literally all we're going to do in this first example is I'm going to make sure you can find this button on your calculator. So I'm going to zoom out so you can see my hand because it's kind of down at the bottom of the calculator. All right, so E should be, if you have a graphing calculator, a second function, actually for the scientific also. You want to look for a button that says LN, and it's right, it looks like an I, but it's right next to the 4 button, if you guys have the lovely graphing calculator. So to get it, though, you have to hit second, that LN button. We're going to use the LN button today, too. But second, and then it should literally pop up the E. So I will come help you if you don't see that, but what I'm going to have you guys do, I'll just show you E to the first. That's going to be this number that they've got there, and you can see it's this 2.718. Just wrote the first couple decimal places, but you can just get E by itself. If you want to do E to the third, if I pop that, it'll automatically pop up the ability for you to put an exponent in there, and so you're just going to type in, like for this first one, we're just going to type in 3. And these questions, just in general, are going to ask you to go 3 decimal places, the nearest thousandth. So 1,000 has 3 zeros, so we're going to go 3 decimal places. Sorry, guys, this looks really out of focus. So I'm going to do 20.086 to 3 decimal places. All right, now for E to the -4th, and E to the 1/2. You absolutely don't have to write this. You can just type it in your calculator, but I want you to think about this for a second. E to the -4th is going to be a decimal because this would be the same as 1 over, like a little more than 2 to the 4th power, so this is going to be a decimal. And for this one, the 1/2 power, this is the same thing as a square root. So just to think about that when you're looking at the decimals, wondering if you're getting it correct. So for E to the -4th, I'm just going to hit that second, find that natural log button, or the L, it says LN on it, and just use your negative key, don't use the subtraction key. So this is going to be 0.018, right, to 3 decimal places. That's literally all you have to do. And then the last one, I'm just going to do second, that little natural log button, and I'm just going to type 0.5. You could do a half if you want to, but I'm just going to do 0.5. And this guy's going to be about 1.649. Now, if you're not getting that, if you did 1/2, let me show you this real quick. If you have an 84 like mine up here, I could do 1 divided by 2, and I can see that in the exponent. If you're not getting that number, if you can't see that, or if you have a scientific, you might have to just put parentheses around the 1 divided by 2, just so as a fraction there. So if you're not getting that, you might just need to put parentheses around that exponent. If you typed the decimal, it wouldn't make a difference. But if you typed it as a fraction, you might need parentheses, just to check. Is anybody not seeing that on their calculator? Okay. Now, I'm going to have you guys do an inverse for me. So I just wrote, this is a lovely exponential equation. I have y equals e to the x. So remember, e is not a variable, it's just that 2.718 number to the x. And if I find the inverse of something, how do I go about doing that? Does anybody remember? We've got y equals e to the x. What do I do to go about finding the inverse of that equation? Nobody remembers? What do you do? Like if you're just finding an inverse, like of a function, how do you do that? You remember? Flip x and y. Yes. Okay. If you don't remember this, what we're going to do This is for, not just, this is an exponential function here, but not for just exponentials. This is for any function. You're going to switch x and y, and then you solve for y, which just means you're going to get y by itself on one side. So I'm going to take this original problem. I had y equals e to the x. So I'm going to write x equals e to the y. Okay, now, how would I get y by itself on one side there? I've got x equals e to the y. Eli, what do you think? Yes, okay. So the lovely base of your exponent, which happens to be e in this lovely problem here, is going to swing to the other side. Now, this becomes then log base e of x is equal to y. Okay, now what we call the natural logarithm is what you actually have in this lovely equation here. The log with a base of e is equal to what we just called the natural log, and that's the button we've just been hitting on the calculator. They abbreviate that. It looks like a capital I, but it's actually a lowercase ln. So ln stands for the natural log, and it's kind of like the common logarithm. When you see it in an equation or something, they'll just write ln. They won't write in the base e. So you want to definitely remember this. The log base e is the same as the natural log. All right, so how I would want to write this inverse here, which is what I'm going to rewrite in 1 second, this would be y equals the natural log of x. That would be the inverse of what we started with y equals e to the x. All right, and so down here, this is just kind of showing you the graph of these two. Sorry, I just scooched that really quickly. The y equals e to the x is going to be this first, that's the exponential. All right, so that's y equals e to the x. And then if you guys remember, the inverse of an exponential is a log, and that's going to take that same shape that we had for our graphs. And you don't have to draw this in. I'm going to just attempt to. They're a reflection of each other if you have inverses over the line y equals x, which would be a perfect diagonal through the first and third quadrants. And it would just be, you'd start at 0, 0, go up 1 over 1, up 1 over 1 to create that line. It's a little hard to do on that picture, but they are inverses of each other. So what we're going to focus on today is going to be the natural log. That would be this graph that I have like in the green. Okay, now I'm going to write one more little note before we try and do some problems here. So natural log, I'm going to write ln, follows all the, it is a log. It's just a special case of a log, so it follows all the log properties we've talked about. So it follows the quotient, the power, and the product properties. So natural log follows, I didn't write that right, follows all the regular log properties that we've talked about. So we're just going to use that today a little bit and simplify. All right, so just like a regular log, it's just like a special case. If you see a number out in front of a natural log, that can be an exponent on whatever follows, the little power rule. So this is really the natural log of 15 squared minus the natural log of 75. 15 squared is, what, 225? Does that sound right, I think? And then, just like a regular log, a natural log would follow the quotient rule. So if I have subtraction, we're going to divide those two numbers. So I'd have 225 divided by 75 if I'm simplifying this down to a single natural log. And let's see if that's a nice number. Yes. All right, so ultimately, this as a single natural log would just be the natural log of 3. So that's got some numbers in it. I'm going to try one with some variables next to this. All right, so I've got 3 times natural log of x plus natural log of y. Okay, somebody raise your hand and tell me, how would you simplify that? I'm going to try and write that as a single natural log. How would you go about doing that one? Go ahead. Perfect. All right. Good deal. All right, so third power, and then you're just going to squish them together. We're going to multiply x to the third y. I can't do anything else there. The previous question we could simplify a little bit because we're working with numbers. And this one we've got variables, so we're going to go, that's as far as we can go. All right. Who wants to try the third one? I've got 5 times natural log of 2 plus the natural log of 3 and then minus the natural log of 4. What might you do first on that one? If I have 5 natural log of 2 for that first term, what is that really? Natural log of what? 32, yes. You would do 2 to the 5th. So this is really natural log of 32. All right, so just simple, that's a little power rule. Now, actually, let me walk through this just a little bit with you because this is important, and I saw a bunch of people mess this up on the quiz. So if you have, I've got 3 natural logs here, right? So I have addition and then I have subtraction. You have to apply the properties as you read that problem from left to right. So the first kind of separation between the natural logs I have there is a plus sign. So I have to do that multiplication first. So we would have natural log, I'll just put this in parentheses to indicate what I'm doing. So I'd have to do the 32 times 3. We'd have to figure out what that was first. And then I have subtract the natural log of 4. So that whole thing would get divided by the natural log of 4. And that matters in your order of operations just like it would for a normal equation. So I'm just going to do 32 times 3, and then we're going to divide that by 4. But you have to do that multiplication first and then the division last because of the way it's written. So this guy would end up being natural log of 24. Sorry, excuse me. Is anybody having a question? Okay. All right. Now I'm going to have you guys solve some equations. So I've got a mix. So I've got log equations and I also have exponential equations here. All right, so the one thing I think with the log equations, this is like a common logarithm where you're not going to see the little base. That makes it a little bit trickier for me. So whenever I see a natural log, I'm going to write in the base so I know what I'm going to swing to the other side to cancel it out. So the only way to get rid of a log, we're going to convert it to an exponential. This is just a natural log. So the base is e. So you're going to use that button on your calculator that we were using at the beginning of class. To get rid of the natural log, I have a single natural log by itself there. You're just going to swing this guy to the other side. And when you do that, that leaves what you were taking the natural log of, which is just the 3x. You don't need the parentheses there. And the other side, we're going to convert to an exponential. So that would be e squared. And most of these I just do right on the calculator screen because they have some really weird answers. But we're going to take that button that we used at the beginning of class and we're going to do e squared, and then we'll divide that by 3 to get our final answer. So just second, and probably your natural log button. To get e, you're going to square that. And then I usually just hit equals. So that's that 2.718 to the second power. And then we're going to take that, and my exponent, or I'm sorry, what I was taking the natural log of was 3x. So I just have to take that, divide by 3 to get my final answer here. And most of these are going to be weird numbers, so don't think you're doing something wrong. So this would be 2.463. And I know we haven't really used it as a main function yet, but these are super easy to check. So if you want to hit that natural log button right next to the 4, I can just do 3 times, and I'm going to do that second answer, which is the negative key, so it'll give me back exactly what I had there. And you can check to see that that'll be equal to 2. So these are easy to check. You just use the natural log button to check it instead of the e, because you're kind of going backwards. All right, now, these two, tiny recommendation. I would tell you, if you have a single natural log or a regular log of some kind, if you have an exponent, what I would actually do, and you can do this 2 different ways, but what I would actually recommend, I would kind of undo that power property and actually bring that down in front. So when I would do that, this would be 5 times natural log of this 1/4 x equals negative 15. Now, the reason I'm doing that, I could do what we did on the last question, right? We could swing the e to the other side, but then I'm going to have to take a fifth root, which is a lot of buttons to push on the calculator. So I'm just trying to save you a second here. If you drag that power down in front, what you could actually do just real quick is just divide by that to get the natural log alone. So I'd have natural log 1/4 x equals -3, and then we could just go from there. That's a little bit easier than taking a fifth root. You can do both, we'd get the answer the same, but just a little thing that might give you a little bit extra time. Don't forget, natural log has a base of e. The only way to cancel the natural log out is to change it to an exponential. So we're just going to swing that base e to the other side. You're just going to delete the natural log. So this would be 1/4 x. Now, the base of the log, which is e, becomes base for your exponent there. So I'm going to have e that's going to push that -3 up in the air to be in an exponent. And the rest of this I would just do on my calculator. I'm going to do e to the -3rd, and then to get rid of the 1/4, I'm just going to multiply by the reciprocal, which would be 4 there real quick. So I'm just going to do this right on my calculator screen. So just second natural log to get your e, do that to the -3rd power. And then I'm going to multiply that by 4 to get rid of that 1/4. So for this guy, I'm going to go 3 decimal places, 0.199. You guys tried this last one, so it's kind of similar to what we just did. Bless you. Go ahead, try that last one. And if you want to kind of undo the power rule, you can, or if you want to take the cube root, you can do that too. So you can do this one. Anybody feeling good about their? It's got. It'll have 3 decimal places. Anybody feel like their answer is correct, or did you? You could check it. What did we get for this one? What'd you get? 11.389 sounds perfect to me. Did anybody else not get that? Want me to go through it? Okay, good deal. Now, the other ones we're going to do here. This will take no time. This is kind of reversing what we just did. So these are each exponential equations. So you're going to see e in all of these. And at least for the first one, I'm going to write this out, but you don't have to write this out if you understand what I'm going to do here. So the only way to get rid of e is to use a natural log. So let me give you 2 options. If you want to just convert this, you can convert this to a log just by swinging the base to the other side. I'll show you 2 ways to do this. So if I bring that e to the other side, the x minus 3 would come down on the level with the rest of the question. The e becomes the base of the log, so this would be log base e of 55, which really means the natural log of 55. So if you want to just remember, hey, I've got log base e, natural log is what I'm going to use there. Now, all I would do on my calculator, I'm going to add 3 here eventually, but you would just use that natural log button, right? So just natural log, and then type in 55. Now, make sure you close the parentheses or hit equals either way, and then I'm going to add 3 to that to get my answer. So my x value, 7.007. Okay, now, the other option for doing that, if you have e to the x minus 3 equals 55, if you want to remember that e is going to get canceled out by a natural log instead of a regular log, what you do, you would just take the natural log of both sides. All right, when I would do that using the power rule, that x minus 3 would just come down in front, and then the other side would just be natural log of 55. So it's totally up to you. You can take the natural log of both sides, using the power rule would bring that exponent down, and then go from there. And it's pretty much the same work I did on the other question. So whichever one you like better is totally fine with me. I usually just really quick just swing this to the other side to drag the exponent down. But if you want to take natural log of both sides, completely fine. This guy's exponent's a little more complicated. I'd have 8x over 5. The other side, I did log base e of 9, which is just the natural log of 9. If you've got e to a power where your variable's in that exponent, you're going to use a natural log to get rid of it. Now, if I do this one, right, I can just type natural log of 9 right on my calculator. What would you do to get x after you did the natural log of 9? Like, what would your next step be? I've got 8x over 5 equals natural log of 9. So I did natural log of 9. So like, what would you do next? Yeah, get rid of the 5. So I'm just going to do it right on the calculator screen. Just multiply by 5. And then what would you do after that? Divide by 8. And I just keep it right on the calculator screen. That way we're not rounding multiple times as we go through the problem. So should get 1.37. Is anybody having a question? Okay. Now, let's do one more. This one's a little bit more complicated. So what you have to do here, the only thing being taken to the power here where our variable's at in the exponent is e to the 3x. So you actually want to isolate that. So first thing I would do here, get rid of any addition or subtraction. So I'm just going to add 8 to both sides real quick. So we'd have 4e to the 3x. This is going to be equal to 2. All right, now, I am not taking 4 to that power, so I need to get rid of the 4, so I'm going to divide by 2. So then I'm going to have e to the 3x. And if you want to write that as 1/2 or you want to write that as 0.5, whatever's easier, I'm going to write that as 0.5 because it's going to be less buttons to type in my calculator. And then this turns into a problem very similar to the ones we've just been working on. I'm going to grab that e. Base of the exponent becomes base of the log. Just swing that to the other side. When I do that, that drags that exponent of 3x down on the level with the rest of the question. The other side, to get rid of e, you're going to see the natural log. It'd be log base e, which is natural log, and then 0.5 is what I'm going to take the natural log of. So we're just going to do maybe this ln 0.5. Make sure you close the parentheses or hit equals either way. And then I'm going to end up dividing that by 3 to get my answer. And it is completely fine for this to be negative. If I plug that back in, I'm not taking a natural log or a log of a negative number. So it's totally fine. This would go into your exponent. You can have a negative answer. Okay, is anybody having a question?